This question is taken from the Physics Model Paper 2 of 2024-25. Question number 42. 2 point charges of plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meters in air. Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of resultant electric field at O if plus 4 nanocoulomb is replaced by another plus 8 nanocoulomb charge? Now what is given is 2 point charges of plus 4 nanocoulomb and plus 8 nanocoulomb which are separated by a distance of 0.2 meters. So we have two charges Q1 and Q2 which are separated by a distance of 0.2 meters. We need to find the magnitude of the resultant electric field at the midpoint O. So since it is the midpoint and we know the distance between the two charges is 0.2 meters, so this can be written as the distance AO and OB is nothing but 0.2 divided by 2, that is 0.1 meter each. We know that the electric field E1 at point O due to the charge Q1 is given by E1 equal to 1 by 4 pi epsilon naught Q1 by R square. Similarly, the electric field at point O due to the charge Q2 is given by 1 by 4 pi epsilon naught Q2 by R square. Now, if we consider the direction of E1 and E2, we can see that there are two positive charges here. So the direction of E1 is away from the positive charge Q1 and the direction of E2 is away from the positive charge Q2. Since both E1 and E2 are in the opposite direction, the resultant electric field at midpoint O is given by ER equal to E2 minus E1. Now let us substitute the values for E2 and E1. We know that E1 equal to 1 by 4 pi epsilon naught Q1 by R square. So 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 and Q1 is 4 nanocoulomb, that is 4 into 10 to the power of minus 9 divided by R square, that is 0.1 the whole square. So we get 9 into 4 is 36. This both gets cancelled and divided by 0.01 which is equal to 36 divided by 10 to the power of minus 2 or 36 into 10 to the power of 2, or this can be written as 3600 Newton per coulomb. So we got the electric field E1 at midpoint O. Now the electric field E2 at midpoint O is given by 1 by 4 pi epsilon naught Q2 by R square, which is equal to 9 into 10 to the power of 9 into Q2, that is 8 into 10 to the power of minus 9 divided by 0.1 the whole square, which is equal to 8 9s are 72. This will get cancelled and divided by 0.01 which is equal to 72 divided by 10 to the power of minus 2, or you can write this as 72 into 10 to the power of 2 or 7200 Newton per coulomb. Now we can find the resultant ER. ER is given by E2 minus E1, that is nothing but 7200 minus 3600 which is equal to 3600 Newton per coulomb. This is the answer. The magnitude of resultant electric field ER at midpoint O is 3600 Newton per coulomb. Now we have a sub question here. What will be the magnitude of resultant electric field at O if 4 nanocoulomb is replaced by another 8 nanocoulomb charge? Now the question is, in previously this Q1 charge was 4 nanocoulomb and now it is replaced by a plus 8 nanocoulomb. So both the charges are equal here, plus 8 nanocoulomb and plus 8 nanocoulomb. So your E1 and E2 will be equal, that is E1 equal to 1 by 4 pi epsilon naught into Q1 by R square, which is equal to 9 into 10 to the power of 9 into 8 into 10 to the power of minus 9 divided by 0.1 the whole square. So the answer we get is 7200 Newton per Coulomb. Similarly, E2 is also same, that is 4 pi epsilon naught into Q2 by R square, which is equal to 9 into 10 to the power of 9 into 8 into 10 to the power of minus 9 divided by 0.1 the whole square. So the E2 also will get it as 7200 Newton per Coulomb. And the net or the resultant electric field ER equal to E2 minus E1, which is equal to 7200 minus 7200, which is equal to 0 Newton per Coulomb. So the resultant electric field when the 4 nanocoulomb charge is replaced by 8 nanocoulomb charge, since both the charges are equal, the resultant electric field will be 0. This is the answer for the sub question. Therefore, the electric field in the first case is 3600 Newton per Coulomb, and in the second case, when the 4 nanocoulomb charge is replaced by 8 nanocoulomb charge, the electric field in the second case will become 0 Newton per Coulomb. This is the answer. If you find this video helpful, please don't forget to subscribe.